All right, future chemists, welcome. Let's get straight into it. Today, we're going to absolutely nail thermochemistry for your SPM exam. I'll be breaking down everything you need to know to ace this critical topic. Okay, first things first, before we even start, here's your most powerful weapon. Knowing the theory is great, but practice, that's the real game changer. So make sure you head over to mcqspm.com or just grab the app. It's loaded with past year questions so you can take what we cover today and immediately put it to the test. Seriously, that's how you make it stick. So here is the game plan for today. We'll cover your mission, the two big forces at play, how to read the energy blueprints, crush some exam calculations, and then a final debrief so you walk away totally prepared. Let's go. Okay, mission number 1, understanding the flow of energy. So why do we care? Because literally every single chemical reaction involves energy changing hands, usually as heat. If you get this one idea, you've basically got the key to unlock the whole topic. It's that crucial. And you've seen this stuff everywhere. You just might not have called it thermochemistry. You know that cold feeling on your hand when you use hand sanitizer? That's heat being sucked away from your skin. Or when you mix some detergent powder with water and it gets warm? Yep, that's thermochemistry in action. It's happening all around us. All right, so we know energy is always on the move, but where's it going? Well, the cool thing is all of thermochemistry, I mean everything, really just boils down to two fundamental types of reactions, two sides of the same coin. And here they are. It's actually super simple. For exothermic, think exo sounds like exit. Heat is exiting the reaction. The container gets hot. Simple. For endothermic, think endo sounds like enter. Heat has to enter the reaction for it to happen. So it pulls heat from the surroundings, and the container gets cold. That's it. That's the core difference. Yeah, look at this. It's a perfect way to picture it. Exothermic is like a bonfire, right? It's throwing out heat and light. It's releasing energy. Endothermic is more like an ice pack. It doesn't give you coldness. It absorbs heat from your body, which is why it feels cold. It's pulling energy in. Okay, so now we're going to become energy detectives. We're going to learn how to read the blueprints for these reactions, the energy level diagrams. Right, the most important symbol in this whole topic is delta H, or delta H. Think of it as the final score of the energy game. If the score is negative, it means energy was lost or released. That's exothermic. If the score is positive, it means energy was gained or absorbed. That's endothermic. The sign tells you everything. It's that simple. So check out an exothermic diagram. It's like rolling a ball downhill. The reactants start up high with a lot of energy. Then the reaction happens, and the products end up down low with less energy. So where'd that extra energy go? Poof, it's released as heat. That's why delta H is negative. You've gone down the hill. And endothermic? Well, that's the complete opposite. It's pushing that ball uphill. The reactants start low, and you have to pump energy into the system from the surroundings to get the products up to that higher energy level. You're putting energy in, so the surroundings get cold, and delta H is positive. You've climbed the hill. But you know, even to roll the ball downhill, you often need to give it a little nudge first, right? That little push is the activation energy, or EA. It's that initial hump you have to get over to get the whole reaction started. Now, some reactions have a really, really high activation energy. That hump is like a huge mountain. It means it's going to be a super slow reaction because it's just so hard to get it started. So what if we could cheat? What if we could find a shortcut, like a tunnel through that mountain? Well, that's exactly what a catalyst does. And trust me, this is a huge favorite in exams. See? A catalyst creates a brand new path with a much lower hump. It's like digging that tunnel. It makes the reaction go way, way faster. But, and this is super important for your exam, notice how the start and end points are exactly the same. A catalyst does not change the overall delta H. It only makes the journey faster. Okay, enough theory. Let's get our hands dirty. We're heading into the practice arena to tackle some real SPM questions and see how this all plays out. All right, here we go. This is a classic textbook Q equals mcΔT question. You will almost definitely see something like this. Let's break down how to solve it step by step so you never get it wrong. Okay, let's walk through this. Step 1, find your mass, m. And here's the #1 mistake students make. They only use 25. No, you mixed two things together, so you have to use the total volume. 25 plus 25 is 50, so our mass is 50 grams. Then C and delta T are usually just handed to you in the question. Now you just plug those numbers into the formula.
You run the numbers, 50 times 4.2 times 3, and boom, the heat released is 630 joules. Done.
Okay, let's look at another super common exam pattern. This time, they give you the heat of something, in this case displacement, and ask you to calculate the energy. It looks different, but the strategy is always the same. Listen up, because this is the golden rule for these questions. The unit is kilojoules times per mole. That's your clue. It's screaming at you. Find the moles first. So many students try to use the mass directly and get it wrong. Don't be that student. First step, every single time, is convert grams to moles. Mass divided by molar mass. Once you have your moles, it's easy. Just multiply by the heat of displacement they gave you. And just like that, you've got it. 4750 joules. Remember the pattern. See, heat of, think moles first. You'll get it right every time. Fantastic work. We've been through the theory, we've battled some exam questions. Let's do a quick final debrief to lock in everything you need to know. All right, here are your 6 commandments for thermochemistry. 1. Exo releases, delta H is negative. Endo absorbs, delta H is positive. 2. Exo diagrams, products are down. 3. Endo diagrams, products are up. 4. Catalysts just lower the hump. 5. For temperature changes, it's Q equals mcΔT. And 6, for any heat of problem, what do you do first? You find the moles. If you can remember these 6 things, you are absolutely ready. So there you have it. You've cracked the code. You have the knowledge, you have the strategy. Now go practice, get confident, and go conquer that exam. Excellent job today.